Good day, ladies and gentlemen and students. Let's try to understand what is the course. It's about big data, and especially big data with better comprehension for the best course of action. Now, let's be very honest here. Big data is not about beautiful graphs, lots of codes, new information technology, and so on and so forth. In fact, big data is data, information, knowledge, comprehension coming from all different sources, and you would be overwhelmed with the level of information that you would be bombarded with. And this is the point in time where you would have to realize that how you have to learn to sit down, contemplate, and especially contextualize all this knowledge and information and data for your own good use, whether it's a business or even decisions in your personal life, and especially how you would add value to yourself and the stakeholders around you. They may be your customers, they may be your politicians, or whoever it is. So, if you desire to do any of the following, let's say you want to determine different set of correlations, what are the causal interactions, if A causes B or B causes C, or how are they correlated. And likewise, if you want to spot different business trends, find out ways in which diseases are spreading and how you'd like to curtail them, and especially bearing in mind national security agencies who would like to combat crime by seeing how far criminals are using the internet to communicate with each other or to search different concepts in Googles. So, the fact of the matter is, scientists, media professionals, and even governments always come across this massive Great Wall of China like a situation where how they're supposed to manage and analyze so many data sets of terabytes and exabytes, and especially try to use it in the world of finance and business. And scientists have a lot of problem because they have to connect all different type of fields with each other so that they can progress their research, whether it's from the area of meteorology, genomics, connectomics, physics, biology, or even environmental research, to analyze different sets of data to see what kind of a correlation they have. For example, what is the correlation between genomics of bacteria and the role what the environment plays around? What would be the role of climate change on the whole biochemical structure of a bacteria and how that would affect human health? You need to understand that there's a lot of data and a lot of information which has to be crunched to make good use of it. So, what did Google's executive chairman Eric Schmidt say? Since the dawn of civilization till 2003, we have generated 5 exabytes of data. Now, 5 exabytes of data is as per human calculation. There might be much more infinite bytes of data which we haven't really understood. So for convenience it's 5. But honestly, the way in which people are collecting data from all sorts of sources and the kind of volume, looks like we have reached 5 exabytes in just a couple of days, and the pace is going faster. So what is the goal of this course? Very frankly, you're not going to have these discussions on information technology systems, algorithms, programming languages, or things like MapReduce or Hadoop, because please bear in mind, what is the point of knowing all these tools if you don't know how to use them and in what context to use them? There's no point in knowing how a screwdriver works or even how a spanner works if you don't know how to build an automobile. Okay? Just because you have the knowledge of a drill does not mean that you can actually build an automobile and build a safer automobile at a very low cost for your consumer. So please bear in mind, in the world of big data, you have first massively overwhelming quantity of data from all sorts of sources. Your fridge which communicates to the grocery store, your social media interactions via Facebook and Twitter, and how electricity planning systems either by a private company or a state keep on interacting with each other to find out where there's less power requirements or more power requirements. And believe me, it's going to be a lot more than just writing algorithms or reprogramming IT systems, because you have to know what it is being used for in the first place. Because sitting and crunching data in front of a computer won't really serve any purpose to yourself or to who you're working for. So please ask yourself this question: what do you really want to achieve from all this data? Do you want to increase your sales, track different political opinions? If there's some people who have political dissent against the current government. Who are they? Why are they doing it? Whether the government wants to take action against them or not. I mean, come on, these are a few examples. Or even if you want to bring new economic reforms in your country, like infrastructure development or defense expenditure, how you plan to do that? What are going to be the repercussions of one or two or more decisions which are very critical to a nation's success? So big data does help you in all these things. And most importantly, you may think you are using a certain type of data which is enough, but sometimes it's not enough. For example, a teenager who was pregnant and she wanted to hide her pregnancy from her father. Surprisingly, she succeeded, but Google already knew that. Why is it? Because she was searching on Google about issues concerning teenage pregnancies, and when she went shopping, she purchased scent-free soap, vitamins, and calcium tablets, which are specifically for people who are having pregnancies, isn't it? So that's exactly how sometimes Google and shopping malls know more about your family members, and sometimes some even more about yourself than even you would know it. And most importantly, whatever data or knowledge you come across, how do you connect all the dots? And you have to connect the dots based on certain kind of hypothesis or certain kind of theory. For example, some people feel that people who wear a lot of branded clothes or do a lot of fashion somehow are morally inferior or morally shallow. Now, okay, there's some degree of truth to it, but not necessarily that's going to be the absolute truth in every case, isn't it? There may be different cultures, there may be different norms, maybe different circumstances, or there may be so many exceptions to the rule of different kinds. So your hypothesis has to be very robust. And please bear in mind, we humans aspire to do something, so we observe, we measure, most importantly how we measure, and how we connect the dots and how we respond. And again, to see whether our action has really yielded those results, we have to do the whole cycle again. So let's proceed. So why are we doing this thing called big data is to generate value. And how do we define value? Value is different thing for different people. Value for a politician is to have more votes or to be re-elected again. Value for a company is making more profits, having more satisfied customers so that they can come to them again, or maybe even go for a merger and acquisition, isn't it? So as value could be social, financial, or even political gain. And to understand how value can be generated, there will be definitely massive volumes of different types of data coming from everywhere. But as Mr. Amir Kasai said, that even the Googles, the Facebook, or all other kind of existing great IT companies are still finding it difficult to connect the dots effectively and to gain insight as to where this data is being used or where it can actually improve people's lives or improve customer experience. So one point in our human civilization that this can happen is where you have the Internet of Things and a massive convergence between all different systems that we use, right from your cell phone to your computer, to your fridge, to your car, to your bus service, to your government service, and how life can be made better and more comfortable, or in fact much more advanced. So this is where different types of data and a massive infrastructure is being required to contextualize that data into information and how to use it. And most importantly, the same big data will help you evaluate whether how successful your strategy has been. So please bear in mind before we move forward that when you're going to have data, trillions of data coming from all sources, from different places, you are going to be overwhelmed, and the chances are you're going to really drown. So why do we drown? Water coming in from all our directions, overwhelming our senses. We definitely lose our ability to coordinate from our sensory information in our human body. And because we are not able to coordinate all our actions, that is why we drown. That's exactly which will happen in the world of big data. That you're going to have data coming from all places. And if you're not able to understand or contextualize this data, coordinate your different actions and really do something about it, then you'll land up in analysis paralysis and a huge billion-dollar bill for all the big data infrastructure that you have developed. So, ladies and gentlemen, be a big data user and not a loser. So, Just we begin forward, and I have a few words of wisdom that no matter how great your big data is, it definitely needs bigger focus and better ethics. Now, please bear in mind, life started in the form of a single cell. And when it decided to grow, which is to bite more than it can chew, that is the time nature also started to use big data, because for a cell to become into multiple cells, so much of biological information has to be understood, exchanged, responded to. Okay? So that is how we evolved from a single cell. Now, why are we discussing biology? Because let me explain that one step is a giant step for mankind, and the same way we would now be requiring to take baby steps toward our own civilization. And this statement, which was made during the moon mission, okay, the reason for discussing this statement is that the computational power required for the entire moon mission executed by the United States was almost as good as a pocket calculator or even an average cell phone which is available today. So please bear in mind, don't be under the impression that by having tons of different servers and tons of algorithms and various lines of code that you will really be able to do a better job. There is no guarantee. The objective of the day is to realize that you can sometimes do a lot more with a lot less. Okay? So now that we are on the path to understanding the relevance of big data and how to make good use of it, please bear in mind the difference between causality and correlation. For example, one variable may be correlated to the other, but does not mean that variable actually leads to the other situation. It's but natural that when a crow sits on a coconut tree, and does not mean that that's why the coconut falls. The coconut falls because the coconut is ripe and is ready to fall. It's just that maybe the presence of a crow happened to have caused that.